Okay, so geometric probability is the last topic before our test next week, and so it's going to be very similar to basic probability, but we're looking more at geometric shapes. So the first three shapes is, oops, I went down too far, is length. So the first model is the length model when you have a line segment. Okay, so your sample space is all the points on the line. Your event is the points on the line. And so this is how we set up the probability. The one you want over the total. Okay. The next model is angle measure, which comes with circles. How many degrees are in a circle?
360.
360 degrees. Okay, you must know that for the total. For these, they're going to give you a section, and you just have to write that measure over the full 360. Okay, so this table is here to help you. And then the event is they usually say the shaded region when they're asking for these problems. So just make sure you know which part is shaded, which one is not. Oops. Now, the area model, this is why we did area problems for our warm-up, because for area, you have to know, again, the shaded region. So here, what's the shaded region? The triangle. So we would do the area of the triangle divided by the area of the full figure, which is what shape? Rectangle. So area of a triangle divided by the area of the rectangle. So this is why we practice area for our warm-up. Now, let's get started and look at each model. So starting with length. Okay, it says, find the probability that a randomly chosen point on AD is on AB. The first thing I do is calculate the total. So from A to D, what's the total? Total length. 9. How did we do that? Add them up. Add the lengths. 3 plus 4 plus 2. 9. Okay. Now, that's length. I want to know probability. So what is the probability from A to B landing here? 3, right? And what's the total? 9. If we simplify that, we divide by 3, so 1/3 is my probability. For this whole paper and for your homework, we're just going to do decimals. And it wants you to round to the hundreds. So how many zeros are in the number 100? 2 zeros. So that means how many numbers do I need after the decimal? 2. So what is 1/3 as a decimal? 33 repeated, right?
Yep.
So I'll put the bar. Yes. Remember, to get better at your math skills, you have to practice them.
That's what school is.
All right. If you don't like it, get out. BD. What is the length of BD?
6.
6. 6 over 9. Good. Yes, both of these divide by 3. All right, 2/3 as a decimal round to the hundreds. Y'all's favorite number. And that was not on purpose. Okay. All right. Part C says the probability of not landing on CD. So we don't include this length. What is that equal to? 7 over 9. Good. Can we simplify that? No, nothing divides 7 over 9. So 0.7. All right, everybody good on length? Yes? Okay, let's move on to the angles. For the spinner below, find the probability that the pointer lands on section A. Again, what is the full degree of a circle? 360. But I just want to know the chance of landing here. So what degree is that? 100 out of 360. And everyone knows the rule for zeros here. You can cancel them. If you didn't know that rule, you can do that. Why can I not cancel this 0? Yeah, there's is 6, not 0. Okay. So then we can just simplify 10 over 36. Those both divide by 2. So 5 over 18. 5 over 18 is 0.28. So the probability of landing on section A is 28%. Okay, part B. C or D? What does or mean? Both. So what am I going to do? Add. So add D and C. What is that total? 105 out of the 360 degrees. What number divides 105 and 3? What's the highest number that divides? Go higher.
10.
Higher.
11. 10.5.
15. Which is what?
10.
105 divided by 15? 7.
6.
360 divided by 15?
It's, 24. Yeah, 24. Seven over 24.
Yep, which is 0.29. Okay. Alright, C says, what's probably not landing in B? So how could I attack this?
You have to add all the other ones. A, E, and D, and C.
Uh-huh.
Subtract 80 from 360.
Or subtract 80 from 360. I'm just going to do that one because it's just one step. Which is how much? 280. And of course, if you want to double check that you subtracted right, you could add all these. So the chance of not landing on B is 280 out of 360. Cancel the zeros. What divides 28 and 36? The highest number. 4. Good job. 28 divided by 4. 28 divided by 4. 7. 36 divided by 4. 9. And we already have the answer for 7 over 9. It's over here. So 0.7. Okay, how are we feeling so far? Length and circles. We're good? Okay, last one. So this is the area one, which is where your warm-up came from. Okay. It says, find the probability that a point chosen randomly inside the rectangle is in each given shape. Round to the nearest hundredth. I always do the total area first, so let's calculate what shape is the total area. The rectangle. So, how do you find area of a rectangle? Length times width, base times height, same thing. What numbers are those? 20 times.
35.
Good. 35 times 2 is 70. 70 and a 0?
700.
700. Don't forget that when you're calculating area, it's meters squared. Alright, so I have my total. Now, it says, what's the probability of landing in the right triangle? So when we do these, remember, on your table at the top, you do the area of the part you want over the total. So here it says the right triangle. So just since this is our first one doing together, for my visual learners, if you need, this usually helps me. Area of the triangle over area of the rectangle. Okay. So what is the formula for the area of a triangle?
Base times height divided by 2.
For triangles?
Yeah. Base times height divided by 2, or 1/2 base times height, right? Same thing. I'm going to do the 1/2 so we can see it. 1/2 base times height. And then we divide the area of the rectangle, which is base times height. Okay. So we're using that area formula for the shapes in the probability calculation, okay? All right, what is the base for the right triangle here? 16, and the height?
16.
Also 16. Remember, base and height always make perpendicular lines, and so there's a right angle there always. Okay, and then we already did the area of the rectangle. What was it? 700. So I'm just gonna write that. We already calculated it. Okay. Okay, let's punch in some numbers. Half of 16 is 8. 8 times 16. Good. Okay, so this is approximately 128 out of 700, which is 0.18. Okay. All right, this part, this is something to think about. Don't write this. Why would this be wrong? Don't write that because it's wrong. Why would that notation be wrong? Like if you write that on your test, it's gonna be wrong. Why?
Because on the rectangle and it's like edge.
This is a trick question.
It is wrong. You can't put meter squared wide.
Or because like they're both meter squared and they cancel out.
Yes. And we're not calculating area. What are we calculating?
Probability.
Probability. So the only reason I have meters squared here is because I was calculating area, right? But here they do cancel out. That's just area over area, so they cancel. And then technically we're not calculating actual area. We're calculating the probability of landing in the triangle. So just a little remark because some students might do that. All right, trapezoid. Who knows the formula for trapezoid? Anyone?
1/3.
It starts with 1/2. It's very similar to a triangle. 1/2 base times height, but trapezoids don't have one base. How many bases do they have? Two parallel bases. So it's base 1 plus base 2. Yes, times height. Okay, and then rectangle is the same, base times height. Nathaniel, you asleep? Okay, look at your trapezoid. Who are the parallel bases? What side lengths are they? For the trapezoid. 15 and 6. And what is your height? 10. So 1/2 base 1 plus base 2 times 10, and then over base times height of the rectangle. We already know it. 700. 15 plus 6 is 21. 1/2 times 21 times 10. Half of 10 is 5. 21 times 5. 105. We go. The probability of landing in the trapezoid is 105 out of 700 for the area, so that is about 0.15. Good. So 15% is your probability. Okay, last one, the circle. The circle area formula is
Pi r squared.
pi r squared, the infamous pi r squared, over base times height for the rectangle. Okay. Luckily on this image, the radius is given to us. What is it?
4.
4. R equals 4. You have to be careful on your warm-up.
Diameter 1.
Yeah, sometimes they give you the diameter. But not here. So pi 4 squared over 700. Yep. And in your warm-up, it said leave in terms of pi. So again, when you leave something in terms of pi, you don't multiply it. Oops. So this would be 16 pi over 700. But this one tells us to round, so we are going to multiply, and it's going to round to 0.07. All right, we're gluing this in our notebook. Thanks for participating.